Here is an interesting topic. When you are lifting water from well or any types of water sources, when we are going to use H or H by 2 and so on. First of all, we are trying to understand the very first case one, lifting a single bucket, or we can say when we are using the full height. So this is actually a well, and the total height of the well, let's say this is H. Indeed, when we are lifting water from the bottom, it means that the entire mass of the water at the bottom of the water, indeed we have to use H. If a bucket we are using, or maybe a pump, and we have to lift all the water from the bottom, it means point number 2, indeed we also use H. Every part of the water moves the same distance. It means if you install a pipe, say at here, and you are lifting all the water, it will go through or exit from this pipe. Indeed, we also use the value of total height or the full height. In a very specific way, we can say that when the question, the information given as that the value of M is 500 kgs, this is actually a trick. Indeed, you can use the total height. Let's have an example here. A bucket at the bottom of 20-meter well, water is lifted. Indeed, what is the total work done or total energy? So this is a well, and obviously the height H is equals to 20 meter. And let's say within the whole well have got roughly 100 kilogram of water. Indeed, the work done, W is equals to mgh. So the value of M is 100, G is nothing but 9.8, and of course there is a value, M is given, so this will be the full length, which is 20 meter. So this is the answer. So it will be 19600 joule. Hope you understand. If you ask that what is the power of the pump, or the power you spend to lift all this water, indeed you can use P is equals to this W, and how much amount of time requires to lift all the water or lifted out all the water, indeed that time has to be plugged in here. You will get the value of power. So case number 2, pumping all the water out. When we are using actually the half height, it means H by 2. So this is the well from here up to the bottom. The total height is H, and this is the middle position. Here is very important things we need to share, that the top water of the surface of the well moves little, but the bottom water moves a lot. This is very fundamental concept for these types of math. But when we are actually using H by 2, very basic tricks, when M or mass of the water you have to lift it or exit from the well is not given, in that case we have to use H by 2 or maybe H by 3, so on. So of course the total height of the well is h, so in the middle, so this will be half h by 2 and half h by 2. Half h by 2 plus half h by 2 is equals to h, right? So here very important things we have to remember, that the question when asked for different height, first of all, when the question asked for different height, say there one pump is used to half the well, it means we have to take out half of the well, and then we are using another motor or another pump, how long it will take, such type of question when asked. So different height may be asked in a question, or maybe different distance, and in that case we have to use the average height. So the distance here is 0 meter and here is h meter, so average height is initial height plus the final height, the average, there is 2 height, that's why 2, so it will be h by 2. Let's have a question here. So let's understand the problem where actually we are using h by 2 or half of the height of the well. So this is a problem where the height of the well, so this is the well and the height of well is 20 meter. Diameter of the well is 1 meter. So the radius will be 0.5 meter, and t, time requires to empty the well, that is 5 minutes, so 5 times 60 sec, so it will be 300 second. Power needed by the pump. Okay, so this is the final question, power, right? So this is actually the effective power, or P out is equals to mg over the time, and of course the main intention to understand by the problem, that is height. So this will be h by 2. Why? The very fundamental tricks is when the question m is not given, in that case literally we are using h by 2, so far the experience we have gathered. Okay, so here actually no m is given directly in the question, but the volume is given by height and the diameter. Indeed, V is equals to pi r square h. So if we plug in all the value, r is 0.5, h is 20, so 20.5 whole square, and the value of pi after we get 5 pi meter cube, right? So m will be rho times v. So value of rho is 1000 and the value of v is 5 pi, so we'll get 5000 pi kgs. So m we have got right now, so let's plug in from the equation. So value of m is 5000 pi, then g is nothing but 9.8 meter per second square, and h is 20 meter, so 20 by 2 is 10 and time is 300. So the power developed by the pump, that is 5.13 into 10 to the power 3, or we could write down 5.13 kilowatt. So again, when there is no m or mass of the water given, and the water taken from the bottom is not in the question, in that case we have to use h/2 or so on, not the full height. Hope you understand.